She knows some stuff about chemistry. It's Miss Thorn tries to explain. Alright, first things first. Professor Dave, please don't sue me. I'm a big fan of your videos. My students love your videos. I'm just trying to bring a smile to their face in the times of coronavirus quarantine. So, in this lesson, I'm going to go over some stuff that you encountered in the Edible Stoichiometry lesson about building bacon double cheeseburgers. Alright, so let's start out by listing all the ingredients you would need. You are given, to make our bacon double cheeseburger, we're going to need one hamburger bun with the symbol HB. We're going to need 2 patties with the symbol HP. We're going to need 2 slices of cheese, symbol CH, and we're going to need 4 strips of bacon, because why not? Everybody loves bacon. I'm sorry if you are not a fan of bacon or you're a vegan, in which case I apologize. But I love bacon. So, the first thing you had to do was write a balanced equation where the ingredients are combined to form the finished burger product. So you have reactants on one side and products on the other. Using the symbols for each ingredient and coefficients to tell me how many things of each are going into my final product. So that's going to look something like this. HB, because I only have 1, remember, if my coefficient is 1, I do not need to write it. I assume it to be 1. I'm going to need 2 patties, and look how I'm separating my different ingredients with plus signs because they're not bonded, they're still separate. 2 slices of cheese, 4 strips of bacon will produce, and here's the tricky part, because on my product side, everything technically is bonded together. So I want to symbolize that by writing things with subscripts instead of coefficients. So I'm going to move this down a line because I'm going to need some space. But it would look like HB, there's one of those, bonded to HP, 2, subscript 2, cheese, subscript 2, and finally bacon, subscript 4. And then this is one giant thing all bonded together, like a bunch of different elements combining to make one big molecule. So that is your final answer for your equation. And the math that follows has you look at the coefficients to figure out ratios. Alright, so take a look at our equation one more time. I wrote it out and color-coded it so it's a little bit clearer what the ingredients are and how they combine to create our product. I want to go through and first highlight for you what my coefficients are, because that will become important in the next step. Remember, if there isn't anything listed before your atom or molecule, you assume that that coefficient is 1. So really, we have a ratio of 1 to 2 to 2 to 4 on our reactant side, and that will be producing 1 double cheeseburger, bacon double cheeseburger on the other side. So the first question number 1 asks, well, what if I don't want to make 1 cheeseburger? What if I want to make 5 bacon double cheeseburgers? How many of each ingredient would I have to include? So the easiest way to do that is take this ratio and scale it up. We know that we want to end up with 5 burgers. What we need to do is scale up each ingredient according to this ratio so that we end up with the perfect amount of ingredients with nothing left over. So 4 times 5 is 20. We'll need 20 strips of bacon. 2 times 5 is 10. We'll need 10 slices of cheese. 2 times 5 is 10. We'll need 10 patties. And 1 times 5 is 5, so we'll need 5 buns. So that is the answer to the first question. How many hamburger buns do you need? So that's the first one. So in order to make 5 burgers, you would need 5 buns, 10 patties, 10 slices of cheese, and 20 strips of bacon. Done. All right, skip down with me to number 2C. First of all, there is a slight typo. So it says 1 dozen buns, 20 patties, 2 dozen patties. That's supposed to say 2 dozen slices of cheese and 4 dozen strips of bacon. So you have all your ingredients. The question is asking you, if you were given those ingredients and those amounts, how many complete bacon double cheeseburgers could you make? So you're not gonna have a perfect ratio this time, but we gotta figure out what ingredient we would run out of first, and then that is gonna limit how many burgers you can actually make. So let's take a look at that. We've got 12 dozen buns, 20 patties, 2 dozen slices of cheese, and 4 dozen strips of bacon. All right, so if I have 12 buns, I should be able to make 12 burgers with that. If I have 20 patties, each burger needs 2 patties, so I can only make 10 with that. 24 slices of cheese, each burger needs 2, so I can make 12 burgers with that. And 48 strips of bacon, each burger needs 4 strips. I can make 12 burgers with that. So it looks like of all of our ingredients, we would run out of patties first. So that makes, we call that limiting ingredient. The one that runs out first. In chemistry, we would call that the limiting reagent. So when the time comes, I'm gonna have you take this hamburger knowledge and apply it to the actual chemistry. And that's what that means. It's whatever thing you run out of first and limits the amount of product you could make is your limiting reagent. In this case, it's our hamburger patties. So I could only make, to answer that question, I could only make 10 total burgers in that instance. I would have excess buns, excess cheese, and excess bacon, but I could only make 10 total burgers with what I'm given. All right, 2 more quick hints. This one has to do with number 5. It asks you to calculate percent yield, meaning how many burgers out of the total ones were successfully made. So the problem sets you up with, you have fixings for 200 bacon double cheeseburgers. You drop 30 of them. Sad day. So how many, in a percentage-wise, what percentage of the bacon double cheeseburgers did you actually make? So here is your equation. This is just the setup. So let me start here. You want part over whole times 100 to give you your percent yield. So my part is going to be number of successfully made bacon double cheeseburgers. My denominator is going to be the total attempted BDCs times 100. Okay, I'm not going to do the math, that's up to you, but that's the setup. And finally, number 6. So my hint to you for number 6 is color code, color code, color code. Pay attention to the names. So I've written out the equation. Each different item gets its own color. This one is the only one you maybe didn't know the name of it. It's sulfuric acid. H2O, obviously water. These two, you definitely have the ability to name. You have the skills and the knowledge. Sodium hydroxide. And Na2SO4, sodium sulfate. There's a good check of polyatomic ions for you. All right, so treat these questions exactly like you did the cheeseburger questions. Pay attention to coefficients, and remember, if there is no number before that item, assume it to be 1. All right, good luck, guys. I'm on email and Zoom if you need some more guidance. Bye.